think you can see that pretty instantaneously on this occasion, so that's quite good. So can you all see it's just saying projectiles? Can I just double check you can see that? Can somebody just say yes, that you can see that? Yeah. Okay. Right. We're going to start off where we are just projecting something horizontally. So imagine you're on a cliff, you're throwing a ball out to sea, but you throw it horizontally. So you're throwing it straight out in front of you. So we'll come back to this slide, but for the purposes of what I'm talking about, again, is this a good? Yes, good. That was pretty instantaneous. So for all of these questions, this will be the diagram. For today's lesson, you are here and you are projecting a projectile, I should say, horizontally. Okay, so all of these ones today, that's what we're going to be doing. So we're projecting it horizontally. So now what we're going to do, we're going to break the projection down into the horizontal components and the vertical components. Okay, so when you project it horizontally, so the left to right bit, that is not impacted by gravity. Okay, so you've got to get into the habit of, when you're considering the horizontal motion, that there's no gravity in play, so acceleration equals 0, and therefore the distance that you travel is simply the velocity times the time. Just think of it as being from s equals ut plus half at squared. If we don't have any acceleration, that second term disappears, so s equals u times t. Obviously, because we're not accelerating, our speed is constant, so our u equals our v. All right. Alternatively, you can just think of it as coming from this formula here. U and v are the same value. Okay, so you add them together and halve it, it just gives you the same value. So again, you're getting your distance traveled is velocity times time. Okay, rearranged, that's just velocity equals distance over time, which is just your standard sort of pyramid that we use. So that's the key bit. When we're going horizontally, okay, then the acceleration is 0. However, when we're considering the vertical component of the motion, our acceleration equals gravity. So that's just the key bit. So let's just look at a few examples, please. So with all of these, you're going to start off by drawing a diagram. So with example 1, we're told that a particle is projected horizontally at an initial speed of 25 seconds. So that's in our diagram is obviously that. And we're doing this from a point 78.4 meters above a horizontal surface. So we've got that distance being there. And we're building up to working out what x is, the horizontal distance traveled. That's what we're going to be building up to. Now, they're just sort of taking us through this quite nicely, a bit by bit. Obviously, the time taken horizontally and vertically is the same time. Obviously, the time taken to get from here to here, the time is the same for the horizontal components as the vertical components. So in order for us to be working out x, okay, we're going to have to start off by working out the time taken for the whole journey. Okay, now we can do that by just considering the downward components. Okay, if we just start off by resolving vertically, okay, now this is important. Okay, going vertically, our initial speed is 0. Okay, this 25 meters is purely a horizontal speed. The second we project the object, there's no vertical speed to start with. So that's important. The particle is projected horizontally, so the initial speed vertically. And note how they're writing this down. We're saying u with a little lower suffix y. That's because it's the vertical initial speed is 0. So resolving downwards, our initial speed is nothing. We know that we're going a distance of 78.4. Our acceleration is gravity. We don't know what time is. So using that CVAT equation, we can work out the time for the journey is 4 seconds. Now we can go, now that we know the time for the whole journey is 4 seconds, we can go back and resolve horizontally. Okay, now horizontally, our initial speed is 25, our final speed is 25, our acceleration is 0. Okay, we've just worked out the time taken as 4 seconds. And as we were saying on the previous slide, when you're resolving horizontally, S equals V times T, or S equals U times T, it's the same thing. So S equals our initial speed, which is our final speed of 25, times 4. Okay, it's 25 times 4. That gives us our 100 meters being our vertical component. Okay, yes, I think there was a slight lag in the middle of that, and I changed slides. I hope you were still able to follow that. I forgot to look up and check what you were looking at. Okay, so hopefully that's clear enough. So the key things to take from that, in order to work out the time for the journey, we choose to resolve downwards first, because the only unknown downwards is t. Okay, resolving downwards, we know the initial speed, we know the distance on this occasion. They told us the distance on this occasion, and we know acceleration is gravity are unknown. So we had to, given the information we were given, we had to resolve downwards to work out t. Once we knew t, we could then resolve horizontally. So that was example 1. Now, for example 2, you can see we're just given the information a different way around now. We don't know either of the distances, but on this occasion, they do tell us what the time is. We're told that the time is 3 seconds. So the same idea, okay? Let's resolve downwards first of all. The benefit of this is we know what our initial speed is. No, I think we probably could have resolved either of these first on this occasion. I don't think I think we've only got one unknown for both. So I don't think it mattered which way round we did it. But resolving downwards, okay, remember, because we projected horizontally, our initial speed downwards is 0. We're trying to work out this horizontal distance, which is y. Acceleration is gravity. The question tells us the time is 3. Subbing into CVAT, we get y being 44 meters. Then resolving horizontally, we're using this S equals V times T. We can work out that is 45 meters. Okay, so we know the horizontal components, we know the vertical components. Now the question asks us for the distance of the particle from the point of projection when it lands. So we're not trying to work out the total distance travelled, which will be this curvy line. We're just trying to work out how far it is from where we projected it to where we land. That's obviously that diagonal. Okay, so to work that out, we're just using Pythagoras. We know the horizontal component is 45. We know the vertical component is 44.1. Subbing in and using Pythagoras, we can therefore work out that diagonal distance travelled. So for example 2, the two unknowns were the two distances, and we knew the time. And then I think there's a third example here. So what's different? Yes. So same idea, we've just got a different unknown. Okay. On this occasion, they tell us both of the distances. Okay, they tell us both of the distances. We don't know the initial speed, and we don't know the time. Now, if we go and resolve downwards first, and I think with this one you would have had to resolve downwards first. Okay, we know the initial speed downwards is nothing. Okay, we know the distance travelled downwards is 122.5. Our acceleration is gravity. CVAT allows us to work out the t, and because once we know t, we can then resolve vertically to work out what u is. Okay, so we can work out both of the distances. So 3 different examples. where the information was given to us slightly differently. We had different unknowns, but the basics are all the same. If you are resolving horizontally, the u component vertically, your initial speed vertically is nothing. Resolving vertically, acceleration is gravity. Resolving horizontally, the acceleration is nothing, hence why s equals v times t. So what I want us to do, please, for this lesson is to work through exercise 6a. Let me remind myself and when I see you next. Flip back to yes, I don't see you again now until Monday, so I'm hoping we will be able to get through 6a before Monday. I will, as I said, I'm going to stop the recording in a second. You can then ask for any of the slides to be put on the screen. I will go and convert these slides into a PDF in a minute and go and upload them onto Teams, so you can look at these slides, without needing me to change the pages if you want. So let me just stop the recording. Okay. So I know